So now that we've played around with this parabola, we should be able to see that the A value represents the expansion compression factor and also the flipping factor. Okay, and remember this is a vertical expansion and compression. So when we talk about the shape of the parabola, instead of saying wide, we say short. Instead of saying narrow, we say tall. Okay, so this is this factor in here. The opposites, notice it's minus because the opposite sign will shift it to the right and left. So positive shifts it to the left, negative shifts it to the right. The Q factor on the outside of the function, so on things on the outside essentially shift vertically. Okay, so when we talk about the outside of the function is a squared function. Inside is a horizontal effect. On the outside is our vertical effects. So when we start with our original parabola x squared, the positive a is going to make it open up, the negative a is going to make it open down, a small a is a vertical compression, a large a is a vertical expansion, and p is our horizontal and q is our vertical. So when we talk about this graph here, by looking at the equation, we should know what the graph looks like. We can then predict what the graph looks like. So in this case here, the main parts of this are, well, it's always the vertex first. So this is a +3, so that means our vertex got shifted 3 to the left. This is a -1, so the vertex got shifted down. The direction of opening is going to be indicated by that negative, and it's going to be stretched vertically, so it's going to be a little bit taller and thinner parabola. Okay, so when we write these all down, so when we talk about the horizontal shift, okay, the horizontal shift is equal to -3 or 3 left. Okay, our vertical, to locate our vertex, okay, our vertical is going to be -1 or 1 down. Okay, so the location of our vertex, so together this locates our vertex, and our vertex coordinate is going to be at -3 and -1. Okay, so that's the key piece of information. We want to also know the direction of opening. So this opens down, okay, and it is a vertical expansion by 2. Okay. And if we were to sketch this graph, we should have an idea what this graph looks like now, okay, because we know the vertex is going to be at -3, -1, okay, and it's going to be opening down in that direction. And it's hard to show the vertical expansion and compression, but we can try to draw a little bit more taller or narrower. Okay, so that's essentially how the graphing form is the most useful form, because it gives us directly the coordinates of the vertex. So we could do this in the opposite way as well. So in this case, we've been given a point and the vertex. Vertex is key, okay, because vertex is our symmetrical point, and that gives us in fact, double the information. Is worth twice as much to us as any other coordinate. So when we write this equation, it says write the graphing form of the parabola. We're going to have our a value. Well, at this point, we don't know what the a value is, so I'm just going to leave it as an unknown a. But the vertex allows us to put it into the graphing form. So it's 2 to the left, so I'm going to go +2. Make sure you put the squared in there, and it's going to be +2. Okay, so our vertex is generated by, our vertex gives us those 2 points, those 2 values that are p and q values, and vice versa. The p and q values give us the vertex. Now, At this point here, we don't know what the A value is. Now, it's always a good idea to get an idea what this looks like. So I'm just going to sketch this. -2, +2, somewhere on there. And we have a y-intercept somewhere down there. So it looks something like that. Okay, it looks maybe stretched. It's hard to tell, but we definitely know that the A is negative. So how do we find A? Well, one of the truths of any equation is any xy coordinate from this graph can be substituted into x and y. Now, sometimes it gives us something very useful. Sometimes it doesn't do anything. So I'm going to substitute the coordinates back into this equation. Now, we've already used the vertex to generate the equation. So notice what happens when I plug the vertex back in. So I end up with -2 + 2 squared plus 2. I get 2 equals a times 0 squared plus 2. When I solve for this, I basically get 2 equals 2. Nothing wrong with that. So I haven't done anything wrong. So it's never wrong to plug a coordinate into the equation. However, we haven't solved for a. So that's a bit of a problem. And the reason why we haven't solved for a is because we're recycling the same information. We use this information to get the equation. We can't, when we plug it back in, it's not wrong, but it doesn't give us any new information. So what we have to do is plug in the other coordinate. Y is -10, A is 0. And once we do this, this then gives us an equation to solve for A. So we end up with -12 equals 4A. A works out to be -3. Okay, we expected it to be negative because it's pointing down. So then the equation of the parabola is -3 x plus 2 squared plus 2. So there's the equation of the parabola, and it's in the graphing form. So it's important to understand that we can always plug in x and y, okay? And when we're looking for unknown parts of the equation, that other point essentially shows us, when we fix that point, we can see what the graph is going to look like. Okay, the orientation, we can see it's negative. It allows us to calculate that A value, okay, because we can actually see that it's been expanded vertically and flipped. We should be able to algebraically then solve for the factor that does that by using the coordinate 0, -10. So here we're going to do the same thing. We have a vertex, okay? Vertex, very important, because vertex gives us the P and Q values of the graphing form. And we ideally want to use a graphing form because this is the most useful one because it gives us vertex. Okay, so there's our vertex. I can sketch this graph and I can see 1 over 8 up, -348. Oh, I'm going to draw this a little bit differently. 1 over 8 up, -348, maybe somewhere around here. Okay, we know this graph's going to look like that. We've got a symmetrical point over there if you want to find it. So this looks like it's been stretched vertically and it's facing up. That's what A is essentially telling us. So how do we solve for A? We want to use that other point, this point here, right, which kind of gives us an idea of the orientation of the graph. A, which is what A tells us. So we're going to go y equals 48 when x is -3. So we end up with 40 is equal to -4 squared is 16. So A is equal to 40 over 16, which is +2.5. So our equation then, we've now been able to generate the equation of the graphing form by plugging in the vertex. We have one unknown. We can use this coordinate to solve for the unknown by plugging back into the equation. So we end up with 2.5 x minus 1 squared plus 8. And that's our equation of our parabola. Make sure you have some visual sense of it too, because that's very important to have a sense of what these graphs look like.